Hello. In today's video, we're going to show you how to use the lumberg automation Ethernet IP I/O modules in the Rockwell software rslogix5000 programming software for use with any of the Logix PLCs. Now, the first thing you're going to need is the EDS files. Where you can locate these EDS files is www.beldenSolutions.com. Once you've went to that website, you're going to click on the Service tab. Clicking the Service tab is going to open up this section here, and then you're going to click on the Download Center. Once you click the Download Center, you will be shown this page here. Now, rather than search everywhere for all of these different files, what we're going to do is we're going to type in the part number of the actual module that we're looking at. For the Line M modules, you have 0980, ESL, 710, and 711. For the Line R modules, you have 0980, ESL, 811, 812, and 813 modules. For this EDS file, what we're going to search for is the 813. So we're going to type 0980, ESL, 813, and then we're going to click on the search. What should come up, and the first hits should be the EDS files. Now, in the Line R modules, depending on which firmware revision level that you have, you may have the Quick Connect version or the non-Quick Connect version. If all modules shipped today are firmware revision level for Quick Connect. So we're going to go ahead and we're going to download that Quick Connect. So you're going to click on the download. And then you'll click the download button. I've already downloaded the file, so I'm not going to go ahead and I'm not going to do that. So I'm going to click cancel. Let's minimize the screen, and we're at the point now where you have you've got the EDS files already loaded on your PC. Now you need to load them into the PC itself. So using the EDS wizard available through the RSLinks tools program, we're going to click on Add. We're going to launch the EDS wizard and add selected hardware description files. So I click Add. Now, at this point here, you can either add a single file if you just want to add one file, but if you're going to be using multiple modules, I would register a directory of EDS files. Now, what I've done is I've created a directory and I've loaded the EDS files for the Line R and the Line M modules. So I'm going to click on File. I'm going to search. I'm going to come down to my EDS file folder, and that's it right there. And once I click Next, that's going to go through and it's going to install. It's going to do some testing, verify that everything's okay. We have a little yellow icon here on this file, and we have a warning. And that warning is telling us that the data format in the path entry connection 2 is duplicated with previous entries. One of the reasons for that is because I already have these files loaded onto my PC. So I'm not going to go through and click Next and follow this because I've already loaded these. But this is the procedure you'll use to load the EDS files onto your PC. So let's cancel that and exit out of here. The next step, opening up rslogix5000, you've created a project, you've created a controller, and in this case I've created the 1769 L32E PLC. Now, as long as you're running version 20 or later, okay, utilizing the EDS files, you can basically go in and with the add-on profile load a new module in the tree just by searching for the name of the module. Previous to version 20, you had to use the generic Ethernet module. Now, if you are using the generic Ethernet module, I'll point you to the user's manual, which I'll show you in a little bit here. And that user's manual will take you step by step, and it will show you what the assembly instance is and the byte size. Keep in mind that in the lumberg I/O modules, we are using everything as sints, S-I-N-T-S, single integers. These are bytes. So you can see in the controller tag section, we have nothing set up here yet. So let's close this. Let's come down to the Ethernet underneath our port, and let's add a new module. So we right mouse click, new module. Easiest way to search for this, in the search string, type in lumberg. Now, once you've typed in lumberg, any modules that you've loaded the EDS file in through the EDS wizard will show up in the tree. So these are all the different modules that are available. If you'll notice, I also have the new LionP modules, which are available in January of 2016. So for this demonstration, what I want to use is, I like to use the the Quick Connect version of the 813 module. This is the LionR 8 discrete in, 8 discrete out module. So we're going to click that, and we're going to say create. Now, once we've created this module, you need to name this. Now, this name, depending on how you do your programming, is probably going to be representative of where this module is located. So I'm going to call this conveyor 1 input. For IP address, we're going to stick with the basic naming convention of 192.168.1, and let's assign this module 50. So its IP address will be 192.168.1.50. Now next, we want to keep our key compatible module. Can't change any of these. This is the current revision as defined by the EDS file. But now we need to define what type of inputs are we going to be using here and outputs. So we're going to click on the change button. Clicking on the change button, we're going to be looking at the module definitions. So we'll click a down arrow here. If you'd like to use the diagnostics with the inputs and outputs, you can use them here as exclusive owner. If you want to use it just as an input only, you can select this one here. For our demonstration, we're going to click 8 in, 8 out plus diagnostics exclusive owner. Now notice that it puts the assembly instances in there, and it puts in our sizes, and it automatically defines that it's a single integer. Then we're going to click OK. These changes will cause module data types and properties to change. So verify the module properties are OK before applying changes. Change module definition, yes. Once that's complete, we can come up to our connection. The default RPI, or requested packet interval, is 5 milliseconds. Usually what I do is I'll go in and I'll change this to 20 milliseconds. Okay. And at this point here, if you're using a PLC with unicast, you can set up for unicast, or you can set it up for multicast. In this instance, we're going to set it up for unicast. For the input trigger, do we want to use it in cyclic? And that's the only setting that you have available. We have our standard settings down here if we want to inhibit the module, or on a major fault on the controller if the connection fails while it's in run mode. Module information, internet protocol, port configuration, network information will all become available once you're up online and connected to the I/O module with the PLC running. So at this point we can say OK, and we're finished. So we can close that. Now if we look under the tree, there is our 813 module labeled as conveyor 1 input. Now if we come up into the controller tag section, you're going to notice that you have conveyor _1 input .c for your configuration data, I input data, O output data. If you open up the .c, okay, and we go to edit the tags, you can actually come through and you can verify and look at all the different values that are set up in here. For conveyor quick connect, if I click on monitor tags, if you would like to use quick connect with these modules, you need to turn this to a 1. So you'll change that tag to a 1. You can either do it here or you can do it in logic code. It's your choice. Under the inputs data, okay, we have connection folded. This is a tag that's available for you to use. Then we have the data files. Okay, remember that we had 6 SYN files. So there's your files, 0, 1, 2, 3, 4, 5. On the output, we had 8. If you want to understand what this data is, here, open up the manual, and on the 813IO module, if we're using it as Assembly Instance 101, input data with diagnostics, byte 0 through byte 5, this is the information. Basically, your first 2 bytes are going to be the actual input data. X1A is port 1, input A, X1B, port 1, input B, so forth and so on. Then we start with our diagnostics information. You've got SCA, SCS, LVA, LVS, and SCS. If we want to understand what these values represent, scroll down. Input status, as I discussed, X1A, X1B. LVS is your undervoltage for system sensor. LVA is actuator undervoltage. SCS is your sensor short circuit. SCA is your actuator short circuit. And XCS X1 through X4 is sensor short circuit at slots X1 to X4. Remember, this is an 8 in, 8 out. We have 8 ports, 2 signals per port, so we're going to have 4 ports for the input module. Therefore, we only have ports 1 through 4 for short circuit connection. And then we have channel errors for channel A or channel B on the selected ports from 5 through 8. Now, once this information has been entered into the system, you're ready to start programming. Your module, if you actually go online, download this program, your module would be configured and it will be run. If you have any further questions, please feel free to contact us. Thank you.